Hey there, in this video we're talking about the basic parts of a C++ program, and this covers sections 2.1 to 2.3 in the Gaddis C++ textbook. So let's get into it. Here you're seeing on screen the very first program in the textbook actually, and it's titled Program 1.1. It's back in chapter 1 actually. So a fairly short program, and as you can see on the first line, the point of this program is to calculate the user's pay. When this program runs, the user is going to type in their pay rate, the number of hours that they worked in a week, and the program is going to tell them how much total money they should get paid before taxes actually. So this actually has all the basic stuff you need for a standard C++ program, which I like. I'm going to very briefly just point out what the different parts are, and then we'll dig into the details on later slides here. So on line 1, you have a comment where it says this program calculates the user's pay. Remember what we said before, comments are for human readers to understand what the point is, and that's totally ignored by the compiler. On lines 2 and 3, you have directives, which are instructions to the preprocessor that runs right before the compiler, telling the compiler details about how it needs to handle this source code file, actually. Now on line 5, you have the main function header. So every C++ program is going to have a function called main that looks kind of like what you see here on line 5. Now, the main function contains code in its body, and that body starts on line 6 with the open curly brace, and it doesn't end until line 23 with the closing curly brace. So everything from line 6 to 23 is the main function, and all of the code in this particular program is inside that. Line 7 here is our variable declaration phase. And frequently I call that phase 0 actually, because normally programs start with that. So here we are declaring 3 variables, hours, rate, and pay, and they all have the same type double that we're going to be using to store numbers for money. So these are, when we say variables, we are talking about locations to store data, to store numbers. And the compiler is going to take care of where exactly in the main memory system they're getting stored, which makes it a lot easier for programmers compared to what had to happen in the distant past, frankly. So on lines 10 and 11 and 14 and 15, you're seeing input and output statements. We've seen count before. That's the object that does character output from the computer to the screen for us. And then here for the first time, you're seeing syn, which stands for character input, getting information from the person by the keyboard into the computer program. And then it's going to get saved in these variables that you see after the arrow. On line 18, you're seeing some math happen, actually. So the asterisk symbol indicates that multiplication is happening in a computer program. So what's happening there is you're taking the number in the hours variable, the number in the rate variable, multiplying them together, and then the equal sign indicates assignment. The result gets saved in the variable that's named pay there. There's another output statement here on line 21 where it's going to print out, you have earned $ whatever the number is in pay. And then the very last thing in our program is what's called a return statement. Every main function is going to have that. Every program is going to have a main function. And what you see here is as the main function ends and it hands back control back to the operating system, it's going to send a return code to indicate what kind of error occurred. So when we say return 0 here, that means no errors happened. And if for some reason we knew that there was an error, we would hand back 1 or 2 or 3 or something else to indicate a return code. So expect to see that in every single program in C++ right at the end of the main function like this. Okay, so we'll deal with the details on future slides, but I just want to emphasize that the main function is everything from line 6 to 23. That's actually where the code is. To begin with, all of the programs we write will have a main function like this. Later on, we'll be making other functions, but that doesn't happen until chapter 6. And the other thing I want to emphasize is, like we said in the last lecture, is I like to be cognizant of the different phases that my program is going through. So you can see here at line 7, that's data declaration. That's just the setup, basically. The input phase, right, of the 3 phases, the input phase is basically lines 9 to 15. That's where the point is we're getting information from the user. Then phase 2 is the processing phase, and that's just line 18. You take the pay and the rate, and the rate and the number of hours, and you multiply them, and you save them in this pay variable. And then there's this output phase, and that's right at the end, line 21, where they're printing out what got put in the pay variable, which ought to be the weekly pay. Okay, so there's a good example of all three different phases that a standard program goes through. So now that we've been introduced to the basic parts of a C++ program, and we'll talk about details later, let's actually run this program in particular and confirm that we understand what it's actually going to do. So what I've done here is I've gone to the lecture code download for the Gaddis C++ book, and hopefully you have access to this from our class or maybe your instructor. And I've gone into chapter 1, and there's only one single program in chapter 1. It's this one that we're looking at right here, labeled pr11.cpp. So kind of like I've done before, I'm going to put this folder kind of off to the side. I like keeping an eye on it. See what's happening in there. I'm going to double click on this, bring it up in dev C++, right? And that's a complete program in its entirety, so I ought to be able to compile it. And unless there's some really crazy error that's happening here, that ought to make an executable file. And there it is. Great. So there's pr11.exe. There's the machine code, actually. This compilation had 0 errors. If there had been any errors, it wouldn't be able to make the executable file because this wouldn't count as a C++ program. But this one is perfectly fine. So I have my high-level code here in the CPP file. I now have my low-level code in the executable file. And now I can run it and see if this actually works properly. Okay, so when I'm testing a program, I usually start off with something super, super simple. And either I have a test script written down already, or I'm going to put in something so simple I can just understand in my head what the answer is supposed to be. So let's say last week I worked 10 hours, and I'm making $15 an hour. Right, so 10 hours at $15 per hour, pretty clearly that ought to be $150. I'm going to enter here, and what the program says is you have earned $150. So that's a pretty good sign so far that this program is working correctly. But it's pretty easy to have programs that work correctly on one kind of input and then don't actually work correctly on other inputs. So I don't want to test it just once, I want to test it at least a couple times. And for more complicated programs, I test it a whole lot. So keep in mind what we're doing here. We're kind of role-playing in the role of an end user, not a programmer, but some normal person in the world that might want to use a program like this, maybe a customer that we're building software for, perhaps. So I'm thinking, what other kinds of things would a user like that possibly input to the program? So a lot of people work 40 hours a week. Maybe I'll use that. Let's say, for argument's sake, someone's getting paid $12 per hour. Okay, so 40 times 12, I think that ought to be 480, I think. And the program agrees, right? You have earned $480, and that is the correct response to those inputs. I'll do it one more time. And as I test, I tend to pick like slightly more complicated input as we go on. So maybe this particular person that we're currently role-playing, perhaps they worked 25 hours on the week, and maybe their pay rate is $18.50. So I can't entirely do that in my head, but I feel like, one number is a little more than 20, one number is a little less than 20. So just as an estimate, I'm guessing like around $400-ish, something like that. Okay, $462.50. And we could use a calculator to really double check. $462.50. Maybe later on we'll have a way to format a little bit more nicely. Normally you'd like to see for 50 cents .50, but that's really the same number. And so far, this looks to me like this program's working correctly. Okay, so that is this program here, and let's look a little bit more at the details of each of those components we were talking about earlier. Okay, that comment up at the top of the program, and all through the program too. So we talked a little bit about that before, and there's a couple ways of writing comments in C++ now. Remember that the point of comments, they get ignored by the compiler. They're for the human programmer, the human reader. And the point is to explain or document different sections of a program. Now, as you can see up at top, two different ways of making a comment. Don't forget that C++ was originally based on the C language. So in the C language, you only had one way of writing a comment, is you had to write /*, whatever you like, and then //. And that could take up multiple lines, actually. So you might put /* on line 1 and // on line 8 or something, and you can write whatever you want in between, and that counts as a comment. But for shorter stuff, C++ invented a second way. You can see here the C++ style comment is you just write // whatever you want to the end of the line, and C++ just assumes that the end of the line is the end of the comment. So that's if you're just writing a one-line comment, like actually most of that example we just looked at, that'll save you a little bit of typing. But if you have multi-line comments, you are going to have to put // at the beginning of every line. So either one will work. I think you're probably going to see me use the C-style comment for something big and long, probably the header comment right at the top. And then for the rest of the stuff that's short, I tend to use C++ style comments. Look at the examples in the book and you'll kind of pick up on what the habit is. So, of course, again, the whole point here is it's used to tell humans reading the source code what the goal or the purpose of a block of code is, right? You're not just repeating. You would never be repeating what the code says, but you're trying to summarize it or give a heads up about what's about to happen. Comments are going to appear above and before the described code. So you have a comment. Here's what we're about to do. We're about to get the information from the user about their pay rate. And then comes the code that actually does that. Your comments should use complete English sentences for clarity. Again, the point here is to make it as easy to read for other people as possible. So complete English sentences. Start with a capital letter, right? Have everything spelled properly. End with some punctuation, stuff like that. And the whole point from the C++ perspective is these things just get ignored by the compiler because they're for human beings only. Second thing, the include directive, right? You got this #include directive at the top of your program, and you're almost always going to have at least something like that. So that has the format #include and actually the name of a file. In our initial program, we just had one thing there, IO stream, but there's a bunch of other files that you might want to include in your program later, and later you'll see a whole bunch of #includes at the top of your code file. And what that's doing is it's actually in memory, it's inserting another file into your code. You don't actually see that happen because it's all happening in memory as the compiler starts to run. Technically, that's what we'd call a preprocessor directive. There's this preprocessor that runs and modifies the code in memory before the compiler actually kicks in. And you've got to include appropriate definition files before using external functions. So stuff that some other programmer previously wrote, like sin and count and things like that, they are available in C++, but you need to include the definitions so that the compiler knows what you're talking about. And that's what this #include does, is actually copy-paste pre-existing code into your file so the compiler knows how to deal with it. So the one example we've seen so far is this #include bracket IO stream. There is a file somewhere on your machine, once you've installed dev C++, the compiler environment, called IO stream. Don't forget that IO stands for input-output. So that's the file that includes the definitions for like things like sin and count and a whole bunch of other stuff that we'll talk about later. So probably, for the programs we write in this class, you're probably always going to see #include IO stream if you're going to use sin and count. I will say not every program in the world uses sin and count. They might use other things for input and output. So there are programs in the world that don't have #include IO stream, but they're probably going to have to include some other library that does different kinds of input-output. Okay, the next thing you see there's a line that says using namespace std. It's the using namespace directive. So more generally, using namespace, the ID there is the name of some kind of package or library, right? And what that's doing is it's just saving us a little bit of typing time. You absolutely do not need this in your program, but it's going to be saving us a little bit of typing time. It's providing really convenient access to a certain scope, a certain group of functions. So for example, in our program, it says using namespace std, which gives a shortcut to things in the standard library. STD stands for standard library. And there's quite a bit of stuff there, so saving some time accessing it is not the worst thing in the world. Now, some programmers are going to say you should avoid this, right? It's actually a little bit risky if you're working on larger programs and you're using multiple libraries. The multiple libraries might have name collisions. Like one library might use a word this way, and the second library might use the same word. And you might possibly have a name collision, and you might not be aware of which one's being used. Or there might be a whole bunch of stuff in one of the libraries, and someday you make a typographical error, and you accidentally use an object that you didn't intend to, but it'll compile and do something crazy. So you probably want to run into somebody someday that's going to say we shouldn't use using namespace. But the entire Gaddis textbook uses it in every single example. I think that for small programs, it's probably safe. And for beginner programmers, it will save us some time, particularly if you're using a whole lot of sin and couts, which we will be. So all the programs in the book use this, and it's perfectly fine, I think, by our standards. Now, what that's doing is, like in the places where you've seen count, right? If you didn't have using namespace, the full name of that object is really std : count. And so there you're saying, go to the standard library and go get that count object. Technically, that's the full name of it. So by putting in using namespace std, it's saying, hey, compiler, just assume that I put std : in front of everything that I need to. So you could do it either way, right? I've had a couple students say, yeah, I'm going to act professional here. I'm going to skip the using namespace, and I'm just going to write std : count everywhere all the time. And that actually is what professional programmers would do. But on the other hand, they're probably not using sin and count so much as we are. So go ahead and use using namespace. It's perfectly fine. Okay, so then you saw this main function, right? So the function header, int main, empty parentheses, and then you saw curly braces and like about 18 lines or so. That's actually the body of the main function. So that is a program's entry point in C++. And I would say the exact same thing for the C language or the Java language. They all have to have a main function, and that's where every single program starts out at. So for now, all of our program statements are going to be inside the braces of this function. And so for chapters 1, 2, 3, 4, 5, all of our programs will look like this. But remember, this is starter C++ programming. So later, more advanced programs will have a whole bunch of other functions that we'll be writing. And again, that starts happening in chapter 6. Don't forget that the very end of the main function has this return statement, right? It's returning an integer at the end. That's actually why this has to have this int prefix here, right? The header says int main, says when you get done with this main function, we're going to be returning an integer back to the operating system. And sure enough, at the end of the function, we're returning 0, which indicates we had 0 errors. Again, if I did have an error, you'd return 1 or 2 or 3 or something like that. So every single program has a main function. For the moment, all of our code is in there. But later on, don't forget, we will be making a whole lot of other functions. And, at some point, most of your code is in other functions. But this is what it looks like to begin with. Okay, so for the first time in our example, we saw how character input happens from a user on the keyboard into a C++ program. It looks like this. There's this object called sin for character input. And then you have this extraction symbol that's saying we're taking information from the sin from the keyboard, and we're going to save it in this variable location over here. There's a little bit of debate about exactly how you're supposed to pronounce that symbol. On the one hand, it's the extractor symbol. I think technically those are double right angle brackets, technically. That's kind of a mouthful. So normally I just say right arrow when we're talking about it in class. So the point is, it's reading character input, something that somebody typed from the keyboard, and then it stores information over in the variable on the right-hand side. Right? Information's flowing from sin into this variable. So in this example so far, you're seeing one piece of information, one number that's getting stored in one variable. That's not the only thing you can do with it. If for some reason you want to, you can use, on one single line, you can have the user type in multiple pieces of information and save them in multiple variables. So here's an example where I've got sin, right arrow to variable A, right arrow to variable B, right arrow to variable C, and that would let the user type 3 different things. They'd have to separate them with spaces, hit enter, and then the first thing is going in variable A, second thing in variable B, third thing in variable C. So that could save you some typing, right? by getting multiple pieces of information in one line. In that example program, we could have alternatively asked the user, please enter your number of hours worked and your pay rate, and we could have gotten both pieces of input in just one line. And that would have shortened the program a bit. So when SYN's happening and the user working on the keyboard, again, each separate piece of input has to be separated by a space, and then enter actually enters it into the system. Now character output, I mean, we've seen that. So that's the count object. And you see, of course, the count object has an insertion symbol, right? The arrow, or technically the double left angle brackets, is pointing at the count object. So here, information is going from data, like a quote or something, into the count object, which is going to be the console on our monitor. So that is how you're writing character output to the console. So we've seen this before, count, left arrow, how many hours did you work? Prints the string in double quotes. So double quotes indicate what's called a string literal, and that exact thing, that's the thing that's being sent to count, nothing else. Now on the other hand, look at this second example, right? And these are both things in that program 1.1. We have a line that says count, I think this is close to the end, it's count, left arrow, pay, left arrow, ENDL. Those are all letters, ENDL, which is for end line. Notice that there's no quotes there, right? That line is not going to print PAY on the screen. Now you need quotes for that. What that's going to do is, knowing that pay is a variable, it's going to go look up the number being stored in the pay memory location, and that number is going to get printed to the screen, right? And then ENDL, end line, that's actually a symbol indicating an enter key. So it's going to effectively hit enter and then move the console text to another line. So be real careful about the difference of whether you have double quotes, then that exact thing gets printed. If there's no quotes, the compiler is going to assume this has to be a variable, and it will go look at the contents of the variable and print that instead. Big difference, right? So as you see that example, anytime you're going to use SYN, you ought to give a prompt to the user telling the end user what they're going to do next, right, before the SYN happens. So you ought to have a count statement right before a SYN statement, count, tell the user what to do, and then the SYN statement that actually gets their response. That initial count statement is called a prompt. You're prompting the user for something they're about to do, and you use count for that. And here's a little introduction to styling our code, right? This is a human issue. So keep in mind that programmers follow certain styles to make code easy to read for other people, even though these factors are ignored by the compiler. So there's a lot of ways that you could write a piece of code, and technically it is compatible with the technical rules of C++, and it could compile and it could run. But if you hand it off to another person, it would be visually super ugly and difficult to read, and that would make your workplace environment just like really slow as everybody's confused at trying to read other people's code. So we have these common styles that generally C++ programmers follow, that we're in the habit of reading and writing this way, that we found it makes it easier for other people to read and to help us. And here's kind of what I'm talking about with that. So here's a little slice out of that first program, and this is the chunk where we're getting the number of hours worked from the user. It takes 4 lines here. So notice that first of all, line 8, there's a blank line, right? So by setting off this chunk, this particular job with a blank line, it's visually kind of jumps out, and it's easier to spot that this is a section that's meant to be separate from the other sections. Then on line 9, after the blank line, there's a comment, right? We're using the / C++ style comment, and it says, get the number of hours worked. A complete English sentence, starts with a capital letter, ends with some punctuation. I like that a lot. And then after the comment, you actually have the statements. You have the count statement with the prompt, asking the user, how many hours did you work? And of course, the SYN statement, getting their response and putting it into the hours variable. So that's generally what a section of code should look like, and I would recommend that you get in that habit there. A couple more thoughts about that. The comments, right, they're for the human being reader. It should be as easy for the human to read it and to be useful about like alerting them to what's about to happen in the code. Comments should summarize, I would say, like 2 to 5 lines of code, 2 to 5 statements, right? You definitely don't want to use one comment for one statement and one comment for a statement. I mean, you could just read the one statement itself. You don't need a line saying the same thing again. So that would be kind of wasteful. The point here is the comments are meant to summarize. It should definitely be shorter than the statements themselves. Well, definitely, one thing you don't want to do is you don't want to just restate what the code is. So like what I would not want to see for line 9 is I would not want to see a comment that says, I'm going to use count and give a prompt to the user and then use sin and put a number in a variable, right? That's just restating what the code is. Now, if we're programmers, we already see that's what's happening on line 10 and 11. The point of the comment is, what's the point of that, right? From the human perspective, why are we doing this? So the bigger picture on line 9 is we're getting the number of hours worked from the user, right? That's a good quality comment summarizing the goal of these count, sin, quote, variable statements, right? And the other thing I would say about that is I would recommend that you not use end-of-line comments. You are going to see this in the Gaddis textbook once in a while. I guess that's okay for beginner code to try to be super clear. Like on line 11, you could write sin, right arrow, hours, semicolon, and then // and some kind of comment to the end of that line. Some people will do that. I don't think that looks very good, and perhaps more importantly, once you come back to a piece of code and you need to edit it, you'll find that it's a real hassle to maintain those end-of-line comments. If the line gets longer, the comment runs off the end of the screen, and if you tried to line something up nicely, now it's misaligned, and it winds up being more work down the road, and it's also kind of easy to lose the end-of-line comment. So for the purposes of our class, please do not use end-of-line comments like that. Please do what you see on line 9, where you use a full line comment to summarize the next couple of lines of statements. Okay, so there are the different parts of a basic C++ program. And we have a nice example program, and we've seen all the different parts to it and kind of seen the details. So when we're in class again for our course, we would probably do lab 2.1, working with count. Make sure you understand at least how the character output works. So as you can see here on the slide, we get name.cpp if you have access to the lab manual materials. And the point is you're basically going to print your name and some information and your address and your phone number using count and get some practice doing that. It's a pretty good initial lab. So we'll call that for this particular video, and when we come back next time, we're going to be talking more about the variables where we're storing data, which is really important. Variables and identifiers are the next thing. So I'll look forward to seeing you tuning in for that.